This is our last video in Module 6. We're going to cover two extensions of CVP in this video: CVP and activity-based costing, and multi-product CVP. The second part of the video is using Excel, and so I've posted a spreadsheet if you'd like to work along. All right, so this problem is an integration of cost volume profit and activity-based costing. So in our example, Qualcomm Corp, or KC, manufactures electronic components for smartphones. And KC's main product is a chip that sells on average for about $100, and KC expects to sell 150,000 of them next year. Now currently KC manufactures about 70% of the chip in space in a plant they lease from another company that had excess capacity. But KC is considering a new process that would have about 55% of the chip manufactured outside, and they would eliminate some of the costs associated with their own manufacturing. So here's some of the relevant data for KC, and you can see the old process versus the new manufacturing process. So materials and purchase parts were 6 under the old process, but that price has increased to 15 now that they're outsourcing more of the creation of the product. Direct labor is a little bit more expensive, variable overhead is a little bit more expensive, but fixed overhead is down quite a bit from the old process to the new process. In addition, the number of setups is reduced from 3,000 to 2,300. Batch size remains the same, the cost per setup remains the same, but the number of machine hours is going to be saved dramatically as a result of going to the new process. Lastly, general selling and administrative costs are $10 variable per unit and $1.25 million fixed, and those are not expected to change. Okay, so the first thing we need to do is understand a little bit of the activity-based costing info for KC. So setup costs vary with the number of batches, and batch size is fixed, except for the last batch, which might not have a full set of units inside. So using this information, we need to calculate the break-even point. So the first thing we need to do is get the variable cost per unit. So we know that the fixed overhead under the old system, 150,000 units times $40 a unit, that's $6 million. Fixed overhead under the new system is 150,000 times $20 a unit, or $3 million. But what we need to do is back out the setup costs, because that's now an activity that is using a different driver to associate, not to associate, but to allocate overhead costs to each product. So let's pull setup costs out first by calculating it. So we said there would be 3,000 setups in the old system times $300 per setup, or 900,000, which means that the total fixed overhead without setups is under the old system is 5.1 million. The total fixed overhead without setups under the new system is 2.1 million. That's the 3 million minus the 900,000. So the setup cost per batch equals $300. The batch size equals $50. Thus setup cost per unit is 300 divided by 50, or $6 per unit. Okay, now we have the total variable cost per unit. So that is for the old and new systems, the materials and purchase parts, direct labor, variable overhead, and setup costs. We also include the variable SG&A, because remember, under a cost volume profit analysis, we need to capture everything as either a variable cost or a fixed cost. So our total variable costs under the old system were $59.50. Total variable costs under the new system are $74.75. Each product got sold for $100 each, so you can see the contribution margins calculated under the new process and the old process. Okay, to calculate break-even, we're going to use a two-step process. And the first is we're going to estimate break-even using our fixed costs. And then the second step is then to consider our activity-based costing system to true up those estimates. Okay, so we start with total fixed costs without the setup for the old system. That was the 5.1 million. Our remaining fixed costs were the SG&A fixed costs of 1.25 million. So total fixed costs were 6.35 million. Under the new setup, recall that our fixed costs were reduced to 2.1 million without setups, plus the SG&A of 1.25, that's 3.35 million. Okay, so now we can take our fixed cost divided by our contribution margins and get break-even number of units for each process, the old process and the new process. So 6350 divided by $40.50 is about 157,000 units. 3.35 million divided by 2525 is about 132,000 units. Okay, so now we have an estimate of break-even. Let's consider how many batches we would need to make. So since we're doing 50 units a batch, we would take the 156,000 divided by 50 and say, okay, we're going to need to do 3,136 batches under the old system. And under the new system, we would need to do 132,673 units divided by 50, or 2,654 batches. Okay, now that we have the number of batches, we can consider the activity-based costing, right? So 3136 times 300 per batch, 940,800. 2,654 times 300 per batch, 796,200. So now I have my cost per batch. I can recalculate my break-evens and include the cost of the batches as a separate fixed cost. So 6,350, which is the total fixed cost without setup. Now I add in the setup costs under the old system. And notice that I'm going to divide not by 4050, but rather by 4650. Because remember, I included that $6 batch cost as a variable cost in my contribution margin under the first setup because I had to, because the setup costs were not included in there. Now that I'm including setup costs as a fixed cost, of course it doesn't make sense to include that variable cost any longer, so my contribution margins are bumped up by $6. So using this new information, I get a break even of 156,793, and I get a new break even under I got those reversed, the new system of 132,679. So you can see it doesn't make a very big difference, but you can also see that when you do an activity-based analysis of break-even using CVP, you have to find some way to first exclude that separate cost and then go back and include that cost later on. Okay, so for the second part of this, we're going to use Excel. And as I mentioned, I've posted this blank Excel file for you if you'd like to work along. But you'd probably need two pieces of technology, or you do a lot of pausing, entering, and then starting again. So in this particular case, we have a business that has two products, product A and product B. And they're going to sell 18,000 units of product A, and they expect to sell 4,500 units of product B. So that's a total of 22,500 units. And one of the things you typically fix when you do multiple product CVP is you fix the sales mix. So one of the things we need to understand is, what is the sales mix between these two? And the sales mix is simply the pro rata share of each one. So we can figure out what is 18,000 and what is 4,500 as a percent of the total. So you can see that 80% of the products are product A, 20% of the products are product B. Okay, so now we need to calculate the contribution margin for each product. Well, that's pretty simple because we know that the contribution margin is the sales minus the variable cost per unit. We can copy that down and get that the contribution margin for product A is 15 and the contribution margin for product B is 40. Okay, so our next step is to calculate what is the weighted average break even. So in order to do that, the first thing we have to do is calculate the weighted average contribution margin. So that's not a simple average, that's a weighted average. A simple average would be obviously 15 plus 40 divided by 2. But we need to weight that. So the way we're going to do it is we're going to take each sales mix times the contribution margin per unit. That's our weighted average contribution margin that happens to work out to exactly $20. So now we need to figure out, well, what is our break even in units? Well, our fixed costs are given as 400,000. Well, break even is simply our fixed cost divided by our contribution margin per unit, or 20,000 units. And here we can clean that up and make it look nice if we want. There we go. Okay, so now that we have our break even in units, we need to figure out, well, how many of those are units of product A and how many of those units are from product B? Well, that's pretty simple. That is simply the number of total units times the sales mix. There we go. And so now if we're trying to determine what is our break even in terms of dollar sales, that's also pretty simple, right? So that's just the number of units we're going to sell times their selling price. And there we have it. Okay, so the last part is we can use something called goal seek in Excel. And goal seek is wicked cool because what it allows you to do is try to solve the exact same problem we just worked through. Okay, so what we need to do is say, well, look, break even would mean our profit is 0. And we need to figure out how many units we're going to sell in order to make our profit 0. Okay, so you can see I've set up contribution margin to be whatever our contribution margin is. Apparently I have it in the wrong cell. There we go. Okay, so now how many units do I need to sell? So the way you do goal seek is you go to data and you go to what if analysis and you choose goal seek. And you say, look, I want to set this cell equal to 0 by changing this cell. Okay, you ready? Watch what happens. Boom. Is that awesome or what? Totally awesome. So you can see that break even can also be found a little bit easier by simply using the goal seek function. So if you've never used goal seek, hopefully I taught you something new today. Okay, to finish out Module 7, there's a couple of assumptions we use routinely in cost volume profit analysis. And we've talked about some of these a little bit, but we need to make sure that we understand them fully. So the first is we deal inside a relevant range. So recall, Gino's Pizzeria could make 24 pizzas in an hour using a single oven. So that means that oven depreciation costs are fixed as long as our volume is anywhere from 0 to 24 pizzas. But of course, if we need to do more than 24 pizzas, it means we need an additional oven, and thus we would have a new fixed cost structure. So secondly, employees are often considered fixed costs within the relevant range. This is especially true for service companies. So for example, how many cashiers does McDonald's need for 1 to 24 customers? And let's say that's 1. But for more than 24 customers per hour, that would be more than 1. So even though we'd like to think of labor as being variable, that's often not the case. So you need to be a little bit concerned about that. So we also always assume there's a linear association between the units of production, or whatever our activity base is, to be honest, and the costs. So as the number of pizza increases, the costs increase in some linear function. Okay, and we ordinarily think of most costs operating in a linear function, but what if one of the results of the process that we're using to manufacture something is a toxic substance is created? And that toxic substance requires special handling and disposal. And it could be that if we doubled the amount of the pollution we made, it would be more than 2 times the cost. And it could be that if we made 3 times the amount of pollution, it would be more than 3 times the cost. So that would be a non-linear relationship. And as a result, it wouldn't work well for our CVP basic calculations that we've been using. Thus endeth video M9B and Module 6. Good luck with the homework and the quiz. See you in Module 7.